All right, here's our video for chapter 18. Chapter 17, we talked about confidence intervals. Today, we're going to talk about kind of the next big part of this unit, and that is hypothesis testing. So let's take a look at the PowerPoint. Okay. Um, Hypothesis testing, similar to confidence intervals. It's essentially a process of testing how significant the data is, and whether it's valid or not. Particularly, a hypothesis test tells us how likely it would be to get the same results if we repeated the experiment with the exact same parameters. And that kind of tells us how significant the data is. Think about how, like the scientific method, what a hypothesis is. A hypothesis is an educated guess of what you think will happen, and then you conduct the experiment. You collect your data, you analyze your data, and either you can prove that your hypothesis is true, or you prove that it's false. Right? So in stats, we call that guess of what we think is going to happen, we call that the null hypothesis. It's just kind of a special name we give in stats. The null hypothesis is designated, as it says here, with H with a subscript of 0. And again, that is kind of your initial guess of what you think is going to happen. Okay. And then there's also something called the alternative hypothesis, and that is H with a subscript of A. And the null hypothesis is essentially what you would accept as true if the null hypothesis is proven to be false. Okay, so what that means is you have your initial guess, you have your null hypothesis, you collect your data, you analyze your data, and either you prove that null hypothesis, you prove it to be true, or you prove it to be false. If you prove it to be true, then you're done. If you can prove it to be false, then if that is proven to be false, then we accept the alternative as true, the alternative guess. Okay? And the way we decide that is something called the p-value. And we'll talk about how to calculate that. We're going to do that on StatCrunch like we did with confidence intervals. But the p-value is kind of the important thing. Okay, the p-value tells us the probability that we would obtain the same results if the experiment were repeated. Okay, so for example, if you analyze your data and you got a very high p-value, that means you would very much likely get the same results again. Which means that your initial guess is more likely to be true. If you get a very low p-value, that means you're not likely to get the same results again. And obviously that's a problem. If you're not likely to get the same results again, that means your null hypothesis, your initial guess, is more likely to be false. Okay. So the way we're going to conduct a hypothesis test is by using StatCrunch as always. And these are the steps. It's actually the same steps that we did for confidence intervals: stat, proportion stats, one sample, and with summary. Same exact steps. And if you forgot, these are the screenshots of what that looks like. You can see it's the same stuff up here. The only difference is now we're going to go to hypothesis tests instead of confidence intervals. And I'll show you what that looks like through an example. Okay. One thing before I show you the example, one thing I want to point out is right here, this is a drop-down menu. And you could do not equals, you could do less than, or you could do greater than. What you choose in that drop-down menu depends on the wording of the question. And again, I will show you through an example. Okay. And then once you compute this, it will tell you what the p-value is. And the p-value, like I said, determines whether that initial guess is true or not. And this is the criteria we're going to use. Statisticians traditionally use a 5% threshold for p-values. So when you compute and you get your p-value, if you get a p-value that is less than 5%, then again, that's a low p-value. A low p-value means you're not likely to get the same results again if you were to repeat the experiment, which means your initial guess is false. So if your p-value is less than 5%, that means your initial guess, your null hypothesis, is false. And we saw on the last slide, if you prove the null hypothesis to be false, then that automatically means that the alternative is true. Okay. If the opposite happens, if you get a p-value that's greater than 5%, greater than 0.05, then the opposite is true. If you get one that's greater than 5%, that means you are likely to get the same results again, which means your initial guess, your null hypothesis, is likely to be true, and thus your alternative is false. Okay, let's see what that looks like in an example. This was an example I took from the textbook. So let's take a look at that. A news station reported that the national dropout rate last year was 10.3%. One school district reported that 210 of their 1,782 high school students dropped out last year. Is this evidence that the national dropout rate may be increasing? So once again, I went to do this, I went to StatCrunch and I did stat, proportion stats, one sample, and with summary. Okay. And notice I put in my sample size was the 1,782 students, and then 210 of those dropped out. And notice I went to hypothesis test, and I typed in here the percentage. The percentage in this case was 10.3%, which is 0.103 as a decimal. And notice in the drop-down menu here, I chose greater than because of the wording of the question. Is this evidence that the national dropout rate may be increasing? So I chose greater than in there, and I clicked compute. And it gives you a whole bunch of stuff, but we only care about the p-value. Notice in this case, we got a p-value of 0.0196. That is obviously less than 5%. So to go back to the last slide for a second, if we get a p-value of less than 5%, then that means, okay, the criteria just says that our initial guess is false. So let's go back over here, okay? That means our initial guess is false, and thus our alternative is true. Okay. Now, in context, what does that mean? If I look over here, okay, we have proven that this one is false, and we have thus proven that the alternative is true. In other words, that it's greater than 10.3%. So, in context, because the alternative, the greater than, is true, then that means to answer the question, is this evidence that the national dropout rate may be increasing? The answer is yes, it is. Yes, it is increasing. All right. Let's look at the second example. This is another one that I took from the textbook. A magazine is considering launching an online edition. They contacted 400 subscribers at random, and 169 expressed interest in the online edition. The company will only go forward with the plan if more than 35% of current subscribers express interest, should they launch the online edition. So once again, I did the same thing. I did stat, stat. Let's go back here. I went stat, proportion stats, one sample, and with summary. So I went to that. And I put in my data, 169 out of 400 expressed interest in an online edition. Notice I put in 0.35 here. And notice I chose greater than because the company will go forward if more, so greater than 35% of current subscribers expressed interest. Okay. And I went ahead and clicked computer. Again, if I look at the p-value, the p-value is 0.0012, which is less than 0.05. Okay. And once again, if we go back 2 slides, if we get a p-value that's less than 5%, that means our initial guess is false. Okay? So that means our initial guess is false, and thus our alternative is true. So this is false, the initial guess is false, and our alternative is true, greater than 35%. So that is true, which means that more than 35% of subscribers are interested in the online edition. So to answer the question, should they launch it? Yes, they should. Okay. That is the PowerPoint. So what I'm going to do now is I'm going to go to Math Excel, and I'm going to go to the chapter 17 through 19 assignment. Remember in the chapter 17 video, I did questions 1 through 4. You can see here questions 5 and 6 have to do with with chapter 18. So I'm going to go through right now questions 5 and 6 in that assignment. So let's do that. Okay. So let's take a look at number 5 here. Okay. In 1992, a national vital statistics report indicated that about 3.1% of all births produced twins. Data from a large city hospital found only 12 sets of twins were born to 598 teenage girls. Is the rate of twin births the same among teenage mothers? So state the null and alternative hypothesis. So if we were to go on to StatCrunch and put this in, okay, the question is the rate of twin births the same? Okay. Now that's kind of awkward wording because it doesn't imply greater than and it doesn't imply less than. It doesn't imply either. So if it doesn't imply greater than and doesn't imply less than, then we have to go with the not equals one. Okay. Find the p-value. Select the correct choice below, and if necessary, fill in the answer box to complete your choice. So let's go to StatCrunch. So again, we're going to go stat, proportion stats, one sample with summary. Stat, proportion stats, one sample with summary. All right, and if we go to our thing, it was 12 out of 598. So 12 out of 598. Okay. Our percentage is 3.1%. So 0.031 is the decimal. And we had already said that we were going to choose not equals here. Okay. And if we compute that, let's see, our p-value is that, what does it say to round to? It says round to 3. So that's going to be 0.123 is our p-value. Okay. So 0.123 is our p-value. And if we remember, let's go back to the PowerPoint for a second. All right, 0.123, that is obviously, that's what, 12.3%? That's obviously bigger than 5%. And if it's bigger than 5%, that means our initial guess is true, and thus our alternative is false. So in this case, we're saying that this is true, and the not equals part is false. So that means that this part here is false. All right. So in this case, is it different or is it not different? We just proved the not equals part is false. So that means that they're the same or not different. Okay. So we proved that the equals part is true. They're the same. Same means not different. Okay. Number 6. Okay. In the 1980s, it was generally believed that congenital abnormalities affected about 8% of a large nation's children. Some believe that the increase in the number of chemicals in the environment has led to an increase in the incidence of abnormalities. A recent study examined 423 randomly selected children and found that 38 of them showed signs of abnormality. Is this strong evidence that the risk has increased? Okay. Keyword in this case is increased. That means we're going to choose the greater than. Okay. Perform the mechanics of the test. What is the p-value? So we're going to do the exact same thing again. Let's get rid of this. So stat, excuse me, proportion stats, one sample with summary. So what was it? It was 38 out of 423. So 38 out of 423. Okay. And our percentage was 8%. So this is going to be, I'm going to change this to 0.08. And we had already decided that it was greater than. So we're going to make that a greater than, and we're going to compute. And our p-value is 0.228. Okay. So 0.228, once again, that is bigger than 5%. Okay, and again, we saw that what that means is that the initial guess is true, and thus the alternative is false. So we're saying that this is true and this is false, which means it's not increasing. So that means there is not sufficient evidence that the risk has increased. And there we go. And that is it for Chapter 18. I'll be back with another video for Chapter 19.